All right, the last part of 1.3 deals with functions and difference quotients. Okay, so before I get the question of why do we need to use this, because we're going to be using this later on, and it's really just to kind of give you a little bit of a taste of where we're going with PreCalc and getting into the calculus side of things. Okay, so whenever we use the difference quotient is really trying to find, it's like if I pick 2 points on my graph of whatever my function is, and it's kind of starting to get into the derivative side of it, and as we get into further into PreCalc, it's going to be one thing that we're going to use a lot more. Okay? Because what it does, it talks about the average rate of change, whereas if you have a quadratic or a cube or an exponential, things like that, you want to see how fast does it change over a certain amount of time. Okay? Whereas if it's a curve, it's a little bit harder to understand. So what we do is we basically write this in terms of a slope. Okay? So because we pick 2 lines, usually whenever we talk about a secant line, you're used to talking about it whenever you deal with circles, and 2 points on the circle and it's just a line straight through it. Same idea here, you're picking 2 points on your graph and you're going to run a line through it, and you're trying to figure out what your slope is. Now, in some cases, you're going to have things left over. Like if you would just use a regular linear equation, I'm going to give you a hint. The value that you're going to get is going to be the slope of your line. Okay? Because rate of change of a linear equation is the slope. Right? It's going to be more that whenever we use it in terms of like a quadratic, an exponential, stuff like that, cube, whatever. Okay, so the first thing we need to be able to do is to make sure that we can find and simplify an expression whenever it's not just a numerical value that's plugged in. So like if we have the function of negative 2x squared plus x plus 5. Okay, and instead of plugging in a number like 5 or 7 or negative 2, okay, we're going to plug in basically the first part of the difference quotient, which is the f of x plus h. Okay, the h is really the part whenever we get into the derivative side of things. Okay, that's going to be kind of a random number. Okay, or you know, whenever I was going through, we just called it c for like a constant. Okay, there really is no value currently. Okay. It'll come later whenever you get further into PreCalc and into calculus. So if we have f of x plus h, okay, and I'm just going to plug it in. So if I'm going to have f of x plus h, all I'm going to do is every time there is an x, instead of it being x, it's going to be x plus h. Same idea, if it was a 6, you would plug in 6 and you would go from there. Whereas here we actually have, and I'm just going to extend it and have negative 2 times x plus h, quantity squared, plus x plus h, plus 5. So I want to simplify it. Now, I'm going to go ahead and give you a hint and say this is going to be really long because it's not the full difference quotient. So there's going to be a lot left over, whereas the difference quotient, a lot of things are going to get canceled out, and we'll get to that in a second. So if I'm just going to leave the negative 2, I'm going to square x plus h, so I'm going to have x squared plus 2xh plus h squared plus x plus h plus 5. Distribute that negative 2 to everything inside the parenthesis, and I'm going to get a final answer of negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Again, don't just tell me, Laws, that's really long. What am I going to do with that? It's really just making sure that you can plug in your values there. Okay. On B, we'll actually use the difference, or use the actual formula that we have. So we plugged f of x plus h in. Now, all I'm going to do, I'm going to take what's in the box, and instead of redoing everything, I'm just going to take it and I'm just going to rewrite it right here. Okay? So I'm just going to rewrite everything I have of negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Now, the second part of my difference quotient is to subtract f of x. Well, what is f of x? F of x is negative 2x squared plus x minus, or plus 5. So what's that minus going to do to every sign inside there, or of that equation or function? It's going to change everything, right? So whenever it changes everything, I'm really going to have, so instead of a negative 2x squared, I'm going to have a positive 2x squared. I'm going to have a negative h, and I'm going to have a negative 5. Everything's over h, so h is here. Now, is there anything that's going to go away or anything that's going to cancel? The 5s. So the 5s go away. What else? The x. Anything else? The 2x squared. Okay, so we had all of that stuff, and then realistically a lot of it's just going to go away. So with what I'm actually left with, I'm left with negative 4xh minus 2h squared plus h all over h. Now, what else can I do? Cancel out an h. I can factor out an h, or I can just cancel everything out, right? So it doesn't matter to me as far as how you do it. If you would rather factor out an h and have negative 4x minus 2h plus 1 and divide by h and then cancel everything there, that's fine. Okay, if you just want to cancel, the biggest thing is right here, don't forget to make that a 1. Okay, if a mistake's going to get made, students are just going to cancel it off and they're going to forget about it, that it's really, there's really a 1 there. Okay, now I rearrange mine. Okay, I rearrange mine because it's a slope of a line, right? So if it's a slope of a line, I'm just going to rearrange everything to where it's really a slope of a line like negative 4x plus 1. And then I'm just going to have the minus 2h on the end. Okay, that minus 2h is the part that's going to deal with the derivative stuff whenever we get a little further into the calculus side of things. Okay, but I put it all together because negative 4x plus 1, it looks like a slope of a line. Okay. Now, I don't have, because I don't have my values, I don't have my values of that I'm basically going from, so that's where I'm going to use, my two different values. Okay. I don't have the value, I don't have an x and a y coordinate that I want to find out how fast does it move from this point to that point. That's why that h is there. Okay, that h is there because right now we don't have an actual value or a coordinate that we're trying to figure out. Does that make sense? Okay, so just because there's two variables, don't get all in a tizzy, because we'll use that later whenever we actually have a coordinate, say from -1, -1, 2 to 5, 7, or whatever. Okay, to figure out that rate of change.